So please join me in warmly welcoming Amanda to the voting village.
Thank you. Okay, everyone can hear me? We're good? Okay, just start flailing your arms if you stop being able to hear me and I'll start yelling. So yeah, my name is Amanda Glazer. I'm a PhD student at UC Berkeley in statistics, and today I'm going to talk to you about risk limiting audits. So I'll give an overview essentially of how they work at a high level, and then I'm going to talk about some recent work that we've done to make risk limiting audits efficient for all contests. So this has been a really big advancement because it's made it super feasible and efficient to audit every single contest in an election. So I'll go through that at the end, and also in a couple hours I'm going to have a demo so all of you will be able to see how an audit works and do it yourself with a deck of cards and some dice. So this research is, and everything about this I'm going to present is joint work with Philip Stark, who unfortunately can't be here. Am I echoing a little bit? Oh, good, okay. Philip Stark, who couldn't be here today, he's my PhD advisor and has done tons of work with risk limiting audits, introduced them some number of years ago. And then another grad student, Jake Spurtus, we worked on these methods to audit all contests. And then the data I'm going to talk about today is from Orange County, so I'll talk a lot about them. We're super grateful to all the staff in Orange County who have helped us with getting data from the 2020 and 2022 elections. We were able to go through and simulate an audit on all the contests in those elections, so I'll talk about that extensively. Okay, so first, why audit? I think probably this group of people doesn't need a ton of convincing as to why we should be conducting risk limiting audits, but I'll tell you just briefly. So as you all know, computers are vulnerable to bugs, misconfiguration, hacking. We've seen it here numerous times. Things can go wrong in elections. And even besides that, voters, poll workers, officials, everyone can malfunction, whether it's on purpose or not, things can go wrong. And so generally we want a way to check, especially with something as important as our election outcomes, we want a way to check the results. And we've seen here at DEF CON year after year just how vulnerable our systems are. So here's from the report from a few years ago at DEF CON 25. They said the results were sobering. By the end of the conference, every piece of equipment in the voting village was effectively breached in some manner. Participants with little prior knowledge and only limited tools and resources were quite capable of undermining the confidentiality, integrity, and availability of these systems. So year after year here at this conference, we've seen every single one of these machines be able to be hacked, taken advantage of. And again, we have the same sort of thing, a report a couple years later at DEF CON, same thing, over 100 machines, all of which were hacked into. And so because we have these vulnerabilities coupled with things that are less potentially malicious, just human error, device malfunctioning, we really need a way to check the election results, especially something so important. So that's what I'm going to be talking about today. The point of election audits is to provide voters with evidence that the reported winner in your election actually won the election. So we can't take that for granted. We want a way to check that result. So one thing that's super important here that I'm going to say over and over again in this talk is we have to have a voter verifiable paper audit trail in order to do this, okay? So if we don't have paper from the election that we trust, that we know is kept secure, we could be auditing something where something already went wrong. So if we're auditing paper where the results were flipped, doesn't do any good, because we could check all the paper and still get the wrong outcome. So we have to know that this paper that we're checking, the ballots that we're checking, is correct. If we went through and looked at all of them, we would get the right answer. So I'm going to keep saying that because this doesn't work unless we have that. The paper is kept secure. That's a huge prerequisite for all of this work. So if we have that, then the last thing is we can check it, and that's where we get those post-election audits, which I'm going to talk about today. So this is essentially like a mathematically, statistically rigorous way to check election results. So there's a few ways we could think about doing this. So the first idea is we could do a full hand count. So we could literally look at every single ballot card in an election. Some people are shaking their heads because it's a lot of work. And it's expensive, it's time intensive. We could do it, if we know that that paper was kept secure and we have access to it, but it takes a lot of time, it's really expensive, it's hard to do regularly. But that is one option, okay? The second option, which a lot of states do some form of this is these statutory audits, which essentially you're looking at some fraction of the ballot. So like New York had a law where they would look at 3% of the machines in an election. So not even like 3% of the ballots, just 3% of the machines. Well, you can think about what would go wrong there is if you think about it, you can be like, okay, I'm going to target one machine. There's a 97% chance they're not going to hit that one when they do this audit. Or some states like California, they'll look at some fraction like 1% of the ballots. But another problem with those is a lot of times they don't tell you what to do once you look at the ballot. So you look at 1% of the ballots, you look at 3% of the machines, and you're like, okay, well this doesn't quite match what I thought, but there's not always clear next steps. You don't know what to do. When do you go to a full hand count? How do you know, if it's something that's outside of what it should be? So these are super common, but they don't really give us the statistical guarantees or any sort of more confidence that we would want. So this third idea is risk limiting audits, which is what I'm talking about today. And so this is where we actually have statistical guarantees. We know if the outcome is wrong, we have a certain percentage chance of correcting it, and we're never going to reverse the correct outcome. And so this gives us the type of guarantee we want. It's much more efficient than full hand counts, but it will go to a full hand count if what you're seeing is unusual, which is what you would want. So essentially, in one sentence, the goal of a risk limiting audit is to provide convincing evidence that the reported winner really won or corrects the reported results if not. And again, a risk limiting audit, it's never going to correct an outcome that's already correct. If the reported outcome is true, it's never going to overturn that, and it's going to have some pre-specified chance of correcting a wrong outcome. So that's what a risk limiting audit does. Okay, I told you I was going to say it a bunch of times. I'm going to say it again. We have to have a trustworthy audit trail to do this. Otherwise, it does not work. If the paper is wrong, even looking at all of it, it's not going to give you the right answer. So trustworthy means an accurate tabulation would show you who really won. If you looked at all the paper, you have to know you're going to get the right result. So you have to have that in order to do a risk limiting audits. You want it to be hand-marked paper ballots, voter verified, kept secure. And then once we have that, we can check the reported results by manually inspecting some or all of those paper ballots. Okay, so once we have all that, we can check whether the reported winner really won, which is conducting an RLA or a risk limiting audit. And so the risk and risk limiting audit is a chance of not correcting the outcome if it is wrong. And so that's something you would specify in advance. So you could say, I'm going to do a risk limiting audit with a 5% risk limit, and that means if the outcome's wrong, there's a 5% chance you wouldn't catch it at most, okay? But there's a minimum 95% chance that you would correct that wrong outcome. And you can specify that, you do specify that in advance. So if you want it to be more careful with it, you can say, okay, we want a 1% risk versus, if you don't want that, you could say 10% or whatever you want there. And there's, they've done a variety of risks just in different simulations and different pilot audits. So there's not a standard for that yet. You see 5% come up a lot, but there's not a specific standard set for that yet. So yeah, again, RLAs have a known minimum chance of correcting the outcome if it's wrong and never change the correct outcome. And then the great thing about this is if the outcome is right, which hopefully happens a lot of the time, you don't actually have to look at that many ballots. So it's pretty efficient. You can know with high confidence that the outcome's right and not actually have to look at that many ballots. And so this is where statistics comes in, is that it allows us to use these statistical methods and tools, which I'm not going to go into in great detail, but if you're interested, you can ask me about later. And it uses these tools to guarantee that you have that large chance of correcting a wrong outcome. And with that guarantee, it minimizes the workload. So we want to look at as few ballots as possible to get that guarantee. So like I was saying, you don't always have to look at a lot. So for a ballot polling RLA, which is like far from the most efficient type of RLA, if you have a margin of 10%, it has an expected sample size of 470 ballots, no matter how many ballots are in the election. So you could have 1 million ballots and it would still probably only have to look at a few hundred. And again, this is one of the least efficient types of RLAs. And we'll see an example with Orange County where really you have to look at a pretty small fraction of the ballots for this to work. So that's great. So we're looking at a small fraction. We have a statistical guarantee. We're in a good spot. And if you want to play around with this yourself, this website has some tools where you can put in different margins, numbers of ballots, and you can see for yourself what the sample size would be. So this specific link is for ballot polling RLAs, but if you just not put in the last part of it, you can see for other types of RLAs what the sample size would be. Okay, so that's kind of a basics on what RLAs do. So the next step from this that we were working on is thinking about, okay, we want to audit all contests ideally, because we don't want to just be looking at a specific set of contests. We don't want people to know which types of contests we'd be looking at, because then they could know, oh, they're just going to look at these, so I'm going to change the results in this way. We want to be looking at everything so we know our outcome is correct. And currently, no jurisdiction mandates RLAs of every contest in every election. However, one of the recommendations in the 2018 National Academies of Science, Engineering, and Medicine report, Securing the Vote, said that states should mandate risk-limiting audits prior to the certification of election results. Like we were talking about with the current technology, this requires the use of paper ballots, and that they should do this within a decade and begin pilot programs, which we've seen in some places. And then this last part, that they should be conducted for all federal and state election contests and for local contests where feasible. So this is a recommendation that we do it for all contests. And this is something that is definitely feasible, and I'm going to show you why today. So the question is, how do we do this efficiently? Because we don't want to be in a place where we're like, okay, we audit contest 1, we look at all these ballots, and then we do contest 2, and we keep going. We want to do one sample for a jurisdiction and be able to audit all the contests at once, pulling one sample. So this is our big contribution of late, is a method that takes advantage specifically of that overlap of contests on cards. So the idea here is, if we know on a ballot card which contests are there, then we can take advantage of that and know, okay, well, we pull this card, we can look at all these contests and put that into our calculation and see where the risk goes after that. And I'll show a bunch of examples of this. So how we know this is something called card style, and so that's a collection of contests on a ballot card. So here's an example where we would see for this first ballot card, it's in cart 1, tray 4. It's the 96th ballot card in that tray. And we see it has the California governor's race on it, but not the mayor of Irvine race. And then there would be other contests, yes and no. And then some of these ballot cards do have both the governor and mayor race. And so this is the type of thing we need to be able to efficiently audit all these contests, is we need to know on these ballot cards which contests they contain, because that's going to allow us to target our samples. And that's where it's going to get more efficient. Because otherwise, if you don't know where the ballot cards are, even looking at one contest is going to be hard, because you're going to have to first find where those contests are. So like I was saying, without this card style data, you just don't know which ballots to target to audit a contest. So you could think about, if you're in a county and you're looking at a smaller contest, like for school board, for example, and you have all those ballots together for a county, well, just finding those ballots first is going to take a lot of work. And especially if the margin's small for that contest, you could easily end up looking through all the ballots. And so that's just not efficient. It totally, makes it much less feasible to conduct these. So for example, if we have a contest that's only appearing on 1% of ballot cards, then you would think, you're only going to randomly sample it on average 1 out of every 100 cards. So this is going to up your workload really, really fast. So what this card style data does is it allows us to actually target cards that contain the contest. We're not looking at a population essentially of cards that don't contain the contest. We can target it specifically there, and that's going to make the workload go way down. And it's also going to allow us to take advantage of contest overlap on ballot cards, so we can audit all the contests at once and take advantage of that overlap there. So here's a couple examples of the types of overlap we might see just with 2 contests. So this is kind of a simplified example. So we have a big contest and a small contest. So it could be where the big contest is something like the president. And then the smaller contest is the mayor, which only a particular city is going to have. And so the small contest is going to be on every ballot the big contest is on, but big contest isn't necessarily going to always have that small contest on the ballot. They could not overlap at all, so it could be 2 different mayor races for different cities, and you just never are going to see them on a ballot card at the same time one city's bigger than the other. And then we could have partial overlap for things like maybe school board and propositions where you're going to see them together on some people's ballots, but not all. So there's a lot of different types of overlap, and we want to be aware of all of these and take advantage of it so we know when we pull a card, we're using all the information on the card. Okay, so what we do to do this is something called consistent sampling. And so here's like a very simple example of how it works. So you basically have all these ballot cards. In this case, we have a big contest and small contest. So just two contests again. Sometimes a big contest appears on a ballot card alone, sometimes with the small contest, sometimes small contest is alone. And so you can imagine we take all these ballot cards. In this example, there's not that many. We essentially shuffle them up. In this case, we're giving them a random number between 0 and 1 and then ordering them. That's our way of shuffling them. And then we know from the math behind the risk limiting audit in this case that we have to look at 5 cards containing B and 2 cards containing S. And so we can go here and look, okay, 2 cards containing S, the cut lines here, we get this ballot card and this ballot card. But the nice thing is that this we can use for both. So we need 5 for B, and so the cut line's the solid line here, and we take advantage of 2 that also have S on it. So it allows us to basically, again, a lot of it's like kind of just keeping records, keeping track of what you're doing and being able to take advantage of that and use the overlap. So we're using the cards that contain both. We know they contain both. We're just targeting the ballot cards that would contain either of them, and we're creating a random sample from that. And so this is called consistent sampling, and this is what we do in order to efficiently audit all the contests. So I'm going to give an example from Orange County. So Orange County, it's the 3rd most populous county in California. Here it is here. It's basically a sandwich between LA and San Diego. It had a little over 3 million people as of the 2020 census and close to 2 million active voters. And so it's a pretty big area. And I think simulating and piloting audits in Orange County is going to be analogous to a lot of US states. It actually has more registered voters than 24 US states, and it's the country's 5th largest election jurisdiction after LA, Maricopa, Harris, and San Diego. So it's a really, really large election jurisdiction. And it has 2,204 precincts and approximately 181 voting centers. And so we were able to work with Orange County and get data from the November 2020 and 2022 general elections to estimate how many cards that we would need to inspect to do an RLA with and without style information. So we had worked out kind of the math, done some toy examples, but this was a larger scale simulation where we could actually see, okay, how much difference does this make in something that's going to be on a larger scale, really comparable to a lot of US states. And so here's what we found. So for 2020, we had about 1.5 million voters, a little over 3 million ballot cards. So this was a 2-page ballot, and there were 181 contests. And not taking into account style, we would have had to do a full hand count to audit all the contests. And the reason this is there was, I believe, 1 contest that was a tie in this election. And so you're going to have to look at all the ballots for that. I think that intuitively makes sense, hopefully. And if it was a relatively small contest, and so because of that, if you don't know where the contest is, you're going to have to look at everything because you need all the ballots from that contest. So we're going to have to do a full hand count in a lot of cases with these small margins when we don't know where the ballot cards are. With style, auditing all the contests, our sample size goes down to 20,112. So that's 0.6% of the ballot cards. This is a massive reduction, and if you think about some of these laws that are already looking at like 1% or 3% of the ballots, this is less than that, and we get a statistical guarantee here auditing all the contests. So this is pretty major. And then let's say we want to get rid of some of these smaller margin contests because we think, okay, probably they're going to do a full hand count on these contests anyway, so let's just ignore them and see how that reduces our sample size. And if we omit that 1 contest that was a tie, our sample size goes down to 15,964, so 0.5%. And if we omit the 4 contests that have margins less than 0.5%, our sample size goes down to under 10,000. And we're only looking at 0.3% of the ballots. So this is what I was saying before, that you really don't have to look at that many ballots relative to the size of the election. I mean, we have over 3 million ballot cards, and we're down to looking at like 10, 20,000 of those to make sure we have this rigorous guarantee in all contests. And we see something similar with the 2022 data. So here we had slightly less voters. We had 994,227 voters cast close to 2 million ballot cards in 214 contests. So slightly more contests here. Again, you don't take into account style. You're going to have to go to a full hand count. There's a lot of little contests here with relatively few ballot cards, small margins. You have to find those cards, so you have to go to a full hand count. If we audit with that style data, taking into account all the overlap, all contests, we're looking at 62,251 ballots. So that's about 3% of the ballot cards. And then again, if we omit some of these small margins, because we think, okay, they're going to go to a full hand count anyways, we're down to 1% and almost 0.5%. So we reduce the sample size pretty dramatically. And so this is great because this is relatively little workload compared to, having to look through all the ballots, and it suddenly makes it really feasible to conduct an audit of every single contest in an election. So the crux of this is that RLAs, hopefully I've convinced you, are really important for ensuring elections are trustworthy. The important thing about them is they have this known minimum chance of correcting the outcome if it's wrong, and they're never going to change a correct outcome. And using the card style data, we can make these RLAs efficient and feasible. So we saw with Orange County in the 2020 and 2022 general elections that we would only have to inspect 0.5% or 3% of the ballot cards, and that goes down even more if we take out some of those small margin contests. And I'm going to be doing a demo with cards and dice, like I was saying earlier, at 3:30. It's interactive, so we'll get into groups and everyone can see how an RLA works, because we can all do it. It's a pretty cool process. It's mainly a lot of like accounting and looking for ballots and random sampling. So this is something that every jurisdiction can be doing, that we should be doing. It can give us more faith in the process. That, coupled with having those hand-marked papered ballots that are kept secure. But yeah, hopefully you all will see at 3:30, and I will take any questions now about RLAs, this taking into account overlap, or anything else anyone wants to ask about. Yes?
Right. So you mentioned keeping the ballot secure. What does that look like?
Yeah, and other people might be able to speak better about the security of the ballots than me, but I mean, essentially, you want to know that people don't have access to them. They can't be, you can't lose ballots. No one's going to be able to mess with the ballots in any way. You want to know, at the end of the day, the ballots that you're auditing, if you were to do that full hand count, you would get the right outcome so that they're not tampered with in any way. So the security of that is really important, and there might be others that know like a little bit more about on the ground what the security.
Processes. So is there a process that's written down for security? Yes. Okay, that's actually the question. Okay. Yeah. So is that a national standard? Oh, no. Okay.
So yeah, a lot of things too are done like at a jurisdiction or county level. So that's, I think, too, part of what makes elections a little chaotic, is it's not like there's not one centralized system for this. It's a lot of different jurisdictions doing different things, and so it makes it a lot tougher.
So you audit the ballots that were received and processed, and sometimes there are ballots that are returned as undeliverable because the address doesn't exist. So there's no way that you would be able to clarify or determine if those ballots had found their way into being voted.
Yeah, so essentially a requirement of doing this is we need those hand-marked paper ballots that we know are accurate. So if there's any ballot that was like returned or ambiguous or that they chose not to include, we couldn't, do anything about that. There are specific methods we can do to, like, if we some of the records don't line up, like the card style data and the ballots we have ways where we can essentially like add in buffers to make it a little bit harder to like verify outcomes. So if there's like some ambiguity, there's ways to deal with it statistically, but we really do need like a secure.
No, I'm wondering about ballots that are undeliverable and make their way into the voting system and get counted.
Oh, they do get counted. Okay, so if they're counted and it's something we can go and look at, then there's a couple different ways we could deal with it depending on, what it looks like. So we can assume a worst case scenario there and essentially, not let it add evidence to helping the audit stop. So there's different kind of methods around that. If something is, undeliverable, there's any sort of ambiguity, we can basically assume a worst case scenario there.
Well, in Orange County, there's about 50,000 undeliverable ballots that are returned to the ROV.
Yeah.
Thank you. Okay, so we're inspecting paper because I know sometimes RLAs can be done on ballot images too, right? From the
Yes.
systems. So this requires preservation of the physical ordering of the ballots as they were counted through the machines?
So essentially what you need is, that's a great question. So when we're talking about like card style here, so we need to know where the ballot cards are and what contests appear on them. So there's this question of, okay, well, how do we get that? Where does that come from? And so there's a few different ways. So one, if you're in an area where every precinct, for example, has the same ballot, you might naturally have some of that information, and you would still need information about, the ordering to do the random sample, but at least you would know what contests are on which ballots. Outside of that, you can get information from like that initial scan through of the ballots. You can construct the style data from that, and then there's different safeguards you can put into place to check that the tallies line up, and if they don't, again, adding in some buffer to make things a little bit harder to verify it.
So, but we have to be able to physically locate the actual ballot
Yes.
that's represented by that piece of
Yes.
data. Is that practical in a large environment, like, especially if Orange County said they have like 10,000, or no, how many precincts they have?
So Orange County, and again, this is one of the
2,200
larger
precincts.
ones. Yeah. So they have a lot of precincts.
And a lot of languages, so they've got like a ton of ballot styles, right?
Yeah, I mean, so part of this, so there's kind of a couple sides of this. So one, on our side, doing, the statistics, we're thinking, okay, how can we make this as efficient as possible, meaning, reducing the workload as much as possible while still getting those statistical guarantees, because it is effort to grab the paper, and it's, a massive organizational challenge as well. So that's kind of the first thing, is how much can we reduce the sample size while still getting that statistical guarantee. And then the other side of it is just, making sure things, and this kind of falls more on specific, jurisdictions, to make sure things are organized in a way where it's as easy as possible to pull the paper. And it is, there's no way to get around some amount of work with this, because, to verify a random sample of ballots, it is going to take some work, but there's not a great way around that.
All right, thank you.
So how do you guarantee a random sampling? And the situation that goes through my mind is, in our county, we have a factory that lets out at 3:30 p.m. and everybody goes to the polls.
Yeah.
If we grab from that particular section, that the people that work at that factory are very heavily leaning towards one party versus the other.
Yep.
So wouldn't that potentially skew the results?
Yeah, so essentially, so you're not gonna look at, the first chunk of ballots or a specific chunk. We'll see in the demo, for anyone that stays, this is gonna be like on a smaller scale with 65 cards or ballots. We're gonna roll dice. And then so we're gonna pick okay, the 13th ballot, the 14th ballot, the 25th. And so essentially, you can use a random number generator of some sorts, kind of a larger scale version of rolling dice to then randomly be picking these ballots. And we have different kind of code and software in place to do this and select a random sample of ballots. So that was part of this work, is we have all the code where it will tell you, the expected sample size, which ballots you need to pull, randomly generate those. So it doesn't matter, which you'll see in the demo too, what order the ballots are in, as long as you're randomly picking them, is the big part.
Thank you. I have the dice actually Philip Staub gave me for the first audit here. So I had a question. So when you have to draw ballot number 2,700, and you know that the ballots are all organized in stacks of 500.
Yeah.
Is that okay to just say like, okay, here are 5 stacks, and then go to the last stack and get the one out? What if they're like off by ±1, the other stacks?
Yeah, that's a great question. So this is another thing too we'll see in the demo, because we're gonna make like 6 stacks. And so a lot of this is like very careful organization and accounting work. So you would have a ballot manifest, and it's gonna tell you exactly which stack it's in, which number in the stack. So you don't have to like go through and count every stack. You should, at one point that's done, and then you can know, okay, I need to go to this stack, this tray, this ballot within there. So yeah, a lot of this is you can see like a lot can go wrong at a lot of steps, but it's like very careful accounting and organizational work to make it as easy as possible to know, okay, I need to go here and get this number of ballot from there.
You said it was different across jurisdictions.
How often do they lay the ballots out that way for the results to be? You understand what I'm asking?
Like how often?
So like you're saying they have the stack, the tray, and then the ballot within the, is that a normal way that they keep results if there's paper ballots?
Yeah, I think, I don't know for certain like the numbers of how often, pardon?
If they're doing RLAs.
Not if they're...
Only if they're doing RLAs.
Yeah, so I mean, this becomes like really, really essential when you're doing an RLA, right? Because then you need to know exactly where to go. So I mean, there's a mix. But if you're doing an RLA, this sort of system of knowing, okay, cart, tray, position, and tray, you have to have some sort of information like that, because you have to know where to go. And like, the exact details of it will vary, but yeah, to do an RLA, you'll have to know where to go.
Hello, thank you for the talk. I was wondering, when you're, I guess you would say, pitching this or talking to other local election officials about this, what kind of resistance do you get from people?
Yeah, yeah, it's pretty varied. I mean, some people, of course, like the people in Orange County, great, very, very helpful, want to do everything possible to implement this. There's a variety of things. I mean, we can see this all over the news too. I mean, people don't like admitting that something could go wrong. It's a lot of work, what we were talking about, having to pull all those ballots. I mean, in some sense, there's not a way around the fact that you're going to have to pull 20,000 ballots or some number if you want to do it well. So the workload, not wanting to admit there's anything wrong with their system, I think that's a big thing. Just like I think we see this a lot now, just like denial that anything could go wrong, everything's fine, everything's secure. So I think that's a big one. But yeah, I mean, it's surprising, because I know like when I first learned about all this, I was like, wow, this seems so obvious, especially with something like our elections where, we keep repeatedly seeing issues come up that are very public. We need something like this, but a lot of people don't feel that way, obviously, because, we don't have it everywhere yet, but hopefully with time.
All right, please join me in thanking Amanda for a great